Unit 3, Section 2. I'll finish up our notes for Unit 3 today. We're going to be looking at periodic trends. You guys have already learned a lot about the periodic table, and add to it by giving you some information that will help you later on in the school year as we go through different chapters or different units. All right, so there are specific patterns that you see in the periodic table. A lot of those patterns have to do with the way the atoms behave, how they react. So we're looking at electronegativity, ionization energy, atomic radii, and the ionic radius. So we'll talk about what each one of those things means, and then I'll tell you about the trends. Okay, we're going to start with the atomic radius. Our atomic radius is the distance between an atom's nucleus and its outer electron shell. As you gain shells, of course, to an atom, the bigger the atom gets. And the atomic radius on the periodic table increases from the top right. And as you move across and down, it gets larger. Okay, so the larger ones being down here at the left bottom. And if you look at this picture, this one always helps me to remember. If I picture it in my head, the smallest atomic radii would be up here in this right-hand corner. And as you move across, they get bigger. So you get to the larger ones that are down here on the bottom left. Okay, checks for understanding. Looking at these two diagrams of the protons in the nucleus with the number of electrons in the outer orbital, which one of these scenarios would have the smaller atomic radius? Okay, hint, remember, as nuclear charge increases, there is more attraction to the nucleus, so the atoms get smaller. So out of A and B, which one has the larger nuclear charge? Okay, hopefully you said B, because B has got 2 protons, which means it has a larger nuclear charge. There's some more pluses in there. And with those more pluses in the nucleus, it draws those electrons in, causing the atom to shrink. So your answer for this would be letter B. That would have the smaller atomic radius. All right, ions. You guys need to know a little bit about ions in order to understand the ionization energy and the ionic radius we're about to talk about. So if you remember, ions are charged atoms. We will go into ions a bit more in Unit 4. But ions are made when an atom gains or loses electrons. Okay, so you get a cation when it loses electrons. It becomes more positively charged, and it's called a cation. Okay, if you look at the picture there, for the cation, you have 4 protons and 3 electrons. So you have more positives than you do negatives, which makes it a positively charged ion. And no pun intended here with my little kitty and the cation. She likes to sit on my shoulder. Okay, the other atom on your right there called the anion, it is one that has gained electrons. So it becomes a negative ion. If you look, it's only got 4 protons in the nucleus, but 5 electrons in the orbit, so it's not balanced anymore. It has more of a negative charge, and we call the negatively charged ions anions. All right, look down at the bottom. When you write out ions, they are written as a superscript on the right-hand side of your symbol. So this is iron, and it is a positively charged ion, denoted by the positive charge. And this 3 here is telling you that it has lost 3 electrons. On the other hand, your oxygen over here is an anion, denoted by the negative sign, and the 2 represents the number of electrons this oxygen atom has gained. Okay. Ionic radius, the distance between the nucleus and the outermost electrons of an ion. Okay, the atom's radius changes when it becomes an ion. So when you're looking at cations, these are the positively charged ones. They have less electrons. Of course, they have the same charge in their nucleus. So since they have more protons in the nucleus, it's drawing those electrons in on itself, attracted to the nucleus. So it's causing the radius to be smaller. And these are your metals, which are on the left side of most of them on the left side of the periodic table, from group 1 all the way to 13. And the metals like to give up their electrons, so they tend to have a smaller radius. On the other hand, anions, the more negatively charged ions, they have more electrons. So there's more repulsion from these extra electrons in the orbit. The electrons are pushing out. Okay, so that makes the radius larger. on these, and it tends to be your non-metals, which are going to be on the right-hand side of the periodic table, groups 15 through 17. All right, so checks for understanding. Let's take a look at these. You can pause after each question and see if you can figure out the answer. Which of the following elements has the smallest atomic radius? Remember what we said, it's the cations that have the smaller radius. Okay, so think about your answer there. And, okay, what do you think your answer is? I wish I had a periodic table to show you. I wish I could hold one up. But think about it, we said the metals. So the only two metals in the list are beryllium, which is atomic number of 4, and sodium, which has an atomic number of 11. We said the more protons in the nucleus, the more it draws in the electrons and making it smaller. So since sodium has the larger atomic number, it's got more protons. So your answer is sodium. All right, on the periodic table, which of these describes the tendency of an atomic radii as it's displayed on the periodic table? All right, so take a look at that real quick and let me know what you think. You can pause it. Okay, hopefully you chose letter A for that one. The atomic radii decreases from left to right and across. Okay. All right, the next one, ion with the largest atomic radius. Okay, we said the ions with the bigger atomic radii tend to be the non-metals. So the only two non-metals in that group are fluorine B and bromine C. Okay, you're looking for the one that has the largest number of electrons. Fluorine has 9, plus the one that made it an ion, so 10 in this case. And then bromine usually has 35, and in this case, it's got the extra electrons at 36. So more electrons on the bromine ions, the letter C would be your largest atomic radius. Okay, same question, but this time, which one has the smallest atomic radius? Okay, the smaller atomic radii tend to be the cations. The only cations you have are A and B. All right, taking a look at those. All right, your answer for that one would be sodium. Okay, sodium on that one. All right, moving on. Ionization energy, the amount of energy needed to remove an electron. Okay, the closer the protons and electrons are, the greater the attraction. And of course, the further away they are, the less the attraction. Noble gas configuration, this is telling you that our noble gases, which are over here in our very last column, they all have their outer shell filled with 8 electrons, so they are all happy. We call that the noble gas configuration. And that's what all elements strive to be, is happy and to have their outer shell filled. Okay, so with ionization energy, this is the element that they're trying to, it's basically telling you the energy that's needed to remove electrons. Okay, removing electrons gives them, noble gas configuration, hopefully. And if you think about it, the noble gases themselves are not removing any electrons, so because they already have theirs full and they don't want to give them up. So ionization energy increases going from your bottom left up to your top right. So it means that it requires a heck of a lot of energy up here to get rid of electrons, because they're not going to give them up. They don't want to give them up. These, on the other hand, they have one in their outer shell, and they're like, hey, if I can get rid of this one in my outer shell, then the next shell will be filled and they'll be happy. So that's why the guys over here, these elements, like to give it up so easily. Okay. Which of these statements is an accurate description of the ionization energies of elements in the periodic table? Okay, so take a look at those. And you can pause if you would like, because your answer for this one is letter A, ionization of lithium is greater than that of potassium. The next one, atoms of noble gases are generally inert because, again, if you want to pause, you can, but the reason why the noble gases are inert, which means they don't react, is because J, their outer electron levels are already filled, so they're happy. Electronegativity is a tendency to attract a shared pair of electrons toward itself, okay? Its electronegativity is affected by both its atomic number and the distance at which the valence electrons reside from the nucleus. The electronegativity increases from the bottom to the top and from left to right. Okay, so this means more electronegativity up here and less down here. All right, we have a scale that we use to measure the electronegativity. It's named after Pauling. Of course, that's one of our scientists that we made our timeline from in Unit 2. Fluorine, right here in our periodic table, tends to be the most electronegative element, and it is assigned a value of 4, the highest number on the scale. And the values will range down to cesium and francium, which are the least electronegative at 0.7. And this is just a picture of a periodic table giving you the electronegativities. And you can see here that these are very small. And as you move up across, they get larger and larger until you get the largest one up here at fluorine. All right, which of the following is the most electronegativity value, most likely the electronegativity value for chlorine? You're just basically looking at trends here. Above it is a 4, below it is a 2.8, beside it is 2.5. So which number out of these you think would fit best here for chlorine? I hope you answered letter B, 2.7. Which of the following properties decreases from left to right across a period? Okay, remember our periods are rows. Let's take a look at those. Which one do you think? It is the atomic radius that decreases from left to right and across. Okay. We also have metallic and non-metallic characters. Metallic character refers to the level of reactivity of a metal. Okay, it increases, if you look right here. Metallic character increases going from right to left, top to bottom. If you think about it, these are your metals over here. So of course it would increase as you get closer to the metals or in the metals. Your nonmetals are on this side, which brings us to non-metallic character. Relates to the tendency to accept electrons during chemical reactions. And of course, your non-metallic character will increase as you move towards those. So just kind of, if you remember, metals are on this side, non-metals on this side, and you can remember which way those characteristics increase. Okay, looking at metals and non-metals, non-metals gain electrons to be more like noble gases. So the more electrons they have, the more negative they will be. So they tend to become anions, or negatively charged ions. And metals will lose their electrons real easy to be more like noble gases. So they have less electrons, which means they're going to be more positively charged, and they're going to be the ones that become the cations, or the positively charged ions. So here's a periodic table just to show you the ion forming tendencies, okay, of certain groups denoted by the plus and minus numbers across the top. Okay, so +1 here is indicating that group 1, they like to form cations by losing an electron. Group 2 right here is telling you they like to become cations by losing 2 electrons. Over here, the few that's in this group, they like to become cations by losing 3 electrons. And then you come over here to these 3 groups right here, which is telling you they like to become anions, or negatively charged ions, where nitrogen and phosphorus here like to gain 3 electrons. So they're trying to fill their outer shell, so they can gain, they got spots or room for 3. The oxygen group here, they become anions that like to gain 2 electrons. 2 will fill their outer shell. And then your fluorine group here, they like to become anions. They only need 1 electron to fill their shell. So they become negative ions that gain just 1 electron. And then you see our noble gases here have 0 because they are not gaining anything. They're already full, so they're already happy. They don't become ions at all. All right, what do metals have the largest of? Take a look at the different things we just went over. If you need to go back up and take a look, please do so. See if you can figure out the answer. Pause it here if you need to. But the correct answer for this would be letter B. The metals have the largest atomic radius, and they have the largest, of course, metallic character. All right, based on the periodic trends we discussed, which one of the following ions is most likely plausible? So which one is most likely to be based on what we're just showing on our ion table here? Which one do you think? Okay, the correct answer for this one is letter C, the chlorine, because we said chlorine likes to gain one electron. It becomes a negatively charged ion with just one extra electron. All right, if you need to learn a little more about periodic trends or just have a second person talking about it, sometimes it's good from a different perspective, I've included this video in the Google Slides. You can go open the Google Slides and check out this video. Maybe it'll help you out. Okay, if you have any questions, you guys know where to find me. Just please, shoot me an email or during class time, just ask away. Okay, have a great day.